Hello everyone, my name is Diksha and I am from the Bodhi Academy. I am taking some chapters from 12th standard chemistry and today I'll be continuing with my last part of alcohol phenols chapter, that is preparation of phenols along with the physical properties of alcohols and phenols. Okay, so let us start with the preparation of phenols. So preparation of phenols, first method we will see preparation of phenols from haloarenes. Now in last chapter we already discussed about the haloarenes, right? Haloarenes means benzene with any halide or halogen. So benzene with chlorine is called as chlorobenzene. Okay, chlorobenzene when it is reacted with sodium hydroxide under 623 Kelvin temperature and 300 atmospheric pressure, what do we get? We get sodium phenoxide ion. Okay, sodium phenoxide, which is not stable and which is called as intermediate product. So this sodium phenoxide ion on further acidification, when we add HCl to that, we will get our final product, that is phenol along with the salt NaCl. Okay, so this is a simple reaction in which we just have to use more temperature and pressure. Next is from benzene sulfonic acid. That is what we do here. First, we will convert benzene to benzene sulfonic acid using oleum, and then benzene sulfonic acid is further treated with sodium hydroxide to convert it into sodium phenoxide ion. So when sodium phenoxide ion is generated, it is again treated with an acid, that is HCl, to convert it into a phenol. Okay, so here what we need to remember, whenever we add NaOH, we create a sodium phenoxide ion. And why do we create that? Because it becomes easy to prepare alcohol or the other compounds which you want to convert when you prepared from an ionic form, because it becomes easy to donate to form a bond with the other compounds. Okay, so this is about second method. Now third method is from diazonium salts. Now regarding this, you all must have already studied in your haloalkanes haloarenes chapter the famous Sandmeier's reaction, in which we used to prepare the benzene diazonium chloride from aniline, and after that we used to treat that with the reagent, that is cuprous bromide, cuprous chloride, to get the respective haloarene. Okay, now but here we want phenol. So first we will take aniline as usual. We will treat it with sodium nitride with HCl, and then it is going to give us benzene diazonium chloride. Okay, and this is also not stable. So it is further treated with water, okay, hydrolysis and warmed. So on hydrolysis it will give us the product, that is phenol. Okay, and the N2 and HCl, they will be separated as the side product. So this is the third method from diazonium salt. Then the next method is from cumene. Okay, now what is cumene? Cumene is this. What is this? This is a secondary propyl group or the isopropyl group attached to the benzene. So isopropyl group with O2, oxygen molecule, when you combine, what you are going to get? The two oxygens which we are combining, they will be in between this carbon and hydrogen. So you will get both the oxygen here. Okay, so we will get CH3CO. We will get an acid over here. Okay, that acid, but we don't want acid, so we will convert that further into alcohol. So acid on hydrolysis, we will get an alcohol. So what will happen? The whole group CH3CO CH3, here there will be formation of double bond and we will get this product as a separate product, and this is a ketone. The name of this is acetone. Okay, and this OH group will be attached to the benzene ring, forming our phenol group. So we will get an phenol over here. Okay, so this is the fourth method, which is preparation from cumene. Okay, now these are the four methods from which you can prepare phenols. Okay, now next we will move on to the physical properties of alcohol. So physical properties means what? Basically we will talk about boiling points, melting points and the solubility. Okay, in haloalkanes, haloarenes, we studied about the how physical properties differ, how boiling points differ. Okay, the same criteria applies here, but there will be a slight change that in that chapter we had studied regarding as you increase the molecular mass, the boiling point will increase, or as the more and more groups are attached, more and more alkyl groups are attached to the alcohol, the boiling point will increase. Okay, so as more alkyl groups are attached or more and more groups are attached, the boiling point will be increased. And that should be mostly preferred in a straight chain. Okay, then boiling point will increase. Now one more factor is affecting here in case of alcohol phenol, that is the intermolecular hydrogen bonding. And this is one of the very important factor over here, that is, if you observe, I have drawn the structure of two alcohols. This is one alcohol. See, this is one alcohol, and towards the right there is another alcohol, ROH and ROH. If you see O from this first alcohol and H from the second alcohol, they are forming a bond. Okay, so this is called as intermolecular hydrogen bonding. Even in phenols, if you see this H and this O, they are forming a bond, that is intermolecular hydrogen bonding. So here you can see that they both, meaning the alcohol phenols, they are forming intermolecular hydrogen bonding, and this is very strong bonding. Okay, so if the bonding is strong between them, then it will be difficult to break the bond. So that means we need more temperature. So if we need more temperature, so boiling point will increase. So here the most important factor which affects the boiling point is its intermolecular hydrogen bonding. Okay, so intermolecular hydrogen bonding is very important. Okay. Now let us take examples and discuss the boiling points here. Okay, if you see ethanol, methoxymethane and propane, all of them are having almost equal molecular mass. Okay, so this is having 46, the ether is having 46, and hydrocarbon is also hydrocarbon is having 44, which is close to 46. But if you see their boiling point, they differ. In first example, it is 351 Kelvin. In second, ether it is 248, and in hydrocarbon it is 231 Kelvin. Okay. Now why there is lot of difference? It is affecting alcohol mainly due to the hydrogen bonding, intermolecular hydrogen bonding. So if you see in ethanol, it is very large. So this is due to intermolecular hydrogen bonding. Okay. So this is a very important thing that you have to remember here in physical properties of alcohols and phenols. Then we will talk about ether, methoxymethane. Here boiling point is little less. Here there is no hydrogen bonding. Here there is no intermolecular hydrogen bonding. So that's why it will be less. Though there is a presence of oxygen, but other hydrogen bonding which is strong, which is not present over here. And two alkyl groups are there. Okay. And here there is no oxygen, all the carbon and hydrogen, hydrocarbon. So this will be little less. Okay, so the boiling point differs here mainly due to the intermolecular hydrogen bonding. And also we will talk about the straight chain and branch chain. So as we discussed in the last chapter, the straight chain alcohols they are going to have a large boiling point, and the branch chain alcohols, they are going to have the less value of boiling point. Okay, due to the less surface area. Okay, so this is about the boiling point. And next physical property we will talk about is its solubility. Okay, solubility of alcohols and phenols. Now as we know that there is intermolecular hydrogen bonding in alcohols and phenols. Okay, so this intermolecular hydrogen bonding is playing very important role in some of the physical properties. We will see. Now, if I have this alcohol, ROH, okay, and if I have a water molecule, that is HOH, then also here, this oxygen from alcohol is going to form a bonding with hydrogen from water. Okay, so this is also a hydrogen bonding. So what about the solubility here? Since they are forming a hydrogen bond between each other, the alcohols, they are soluble in water. Alcohols and phenols are soluble in water. Okay, due to the same reason, that is hydrogen bonding. Okay, that's why if you, when we add alcohol to water, you can see that this is miscible or it is soluble with water. Okay. But what happens if you add more and more alkyl groups to the alcohol? If you have alcohol like this, okay, if I have an alcohol which is having three R groups attached to the carbon and OH group, then here the boiling point will decrease. Okay, here boiling point will not increase because of this three R groups or because of more and more alkyl groups, what is going to happen? The polarity between this carbon and oxygen, it is going to become weak. Okay, so since the polarity is becoming weak, the hydrogen bond will not form, meaning the hydrogen bonding will not be stronger. So that's why the boiling point in alcohols which are having more alkyl groups attached to the carbon, they are not going to have more boiling point. Okay, so that's why it will decrease if you attach more and more alkyl groups. So we can say with branching the boiling point decreases. Okay, so this is about the physical properties of alcohols and phenols. I hope you have understood the concepts which I have explained. Okay, so in next video we will be learning about the chemical properties or chemical reactions of alcohols and phenols. Okay, thank you.